Eighth grade, welcome back. We're in week 13 and talking about wave properties still. We're going to be talking about wave interactions and how waves interact with one another and with their surroundings. So today you should be able to understand how wave interactions take place and be able to explain that in detail. Did you ever notice that you can hear an echo of your own voice? An echo occurs when a sound wave bounces back from a surface that it cannot pass through. The woman pictured here is trying to create an echo by shouting towards a large building. When the sound wave strikes the wall of the building, most of them bounce back towards the woman, and she hears an echo of her voice. An echo is just one example of how waves interact with matter. Waves interact with matter in several ways. The interactions occur when waves pass from one medium to another. The types of interactions are reflection, refraction, and diffraction. That should say diffraction, not diffusion, sorry. Each type of interaction is described in detail now. We're going to start with reflection. So in reflection, an echo is bounced back towards the source of the sound. Reflection occurs when waves bounce back from a surface that they cannot pass through. Reflection can happen with any type of waves, not just sound waves. For example, light waves can be reflected. In fact, that's how we see most objects. Light from a light source, such as the sun or a light bulb, shines on the object and some of the light is reflected. When the reflected light enters our eyes, we can see the object. Reflected waves have the same speed and frequency as the original waves before they were reflected. However, the direction of the reflected wave is different. When waves strike an obstacle head on, the reflected wave bounce back, straight back in the direction they came from. When waves strike an object at any other angle, they bounce back at the same angle, but in a different direction. So in the diagram seen here, waves strike a wall at an angle called the angle of incident. The waves are reflected at the same angle called the angle of reflection. But as you can see, it is in a different direction. Notice that both angles are measured relative to a line that is perpendicular to the wall. Refraction is another way that waves interact with matter. Refraction occurs when waves bend as they enter a new medium at an angle. You can see an example of that here. Light bends when it passes from air to water or from water to air. The bending of the light traveling from the fish to the man's eyes causes the fish to appear to be in a different place from where it actually is. Waves bend as they enter a new medium because they start to travel at a different speed in the new medium. For example, light travels more slowly in water than in air. This causes it to refract when it passes from air to water or from water to air. So, where would the fish appear to be if the man looked down at it from straight above its actual location? Take a second and think about that. Pause the video and write down your answer. Welcome back. Have you decided where the fish would appear to be if the man looked straight down at it from straight above? Well, the fish would appear to be where it actually is, because refraction only occurs when waves, in this case, light waves from the fish, enter a new medium at an angle other than 90 degrees. If we're looking straight down at it, the angle of refraction would be 90 degrees. Therefore, the fish would be in the exact spot where we think it is. Let's talk about diffraction. Did you ever notice that you can hear sounds around the corners of buildings even though you can't see around them? In this top figure, we see how this happens. As you can see, sound waves spread out and travel around obstacles. This is called diffraction. It also occurs when waves pass through an opening of an obstacle. All waves may be diffracted, but it is more pronounced in some types of waves than others. For example, sound waves bend around corners much more than light does. That's why you can hear but not see around corners. For a given type of waves, such as sound waves, how much the waves diffract depends on the size of the obstacle, or the opening in the obstacle, and the wavelength of the waves. The picture in the lower right shows how the amount of diffraction is affected by the size of the opening in the barrier. Note that the wavelength of the wave is the distance between the vertical lines. So, in summary, three ways that waves may interact with matter are reflection, refraction, and diffraction. Reflection occurs when waves bounce back from a surface that they cannot pass through. Refraction occurs when waves bend as they enter a new medium at an angle and start traveling at a different speed. Diffraction occurs when waves spread out as they travel around objects or through openings in obstacles. So, three ways that waves interact with matter. So if you can demonstrate your understanding of wave interactions, please move on to the next activity. Otherwise, feel free to go back to the video and review what has been given. Hope you have a great day, and we'll talk again soon.